All right, so we're going to begin by talking about symmetry. And if you think back to when you first started dealing with symmetry, you probably saw a picture of a butterfly, right? And you drew a line right down the middle of that butterfly. And you said it's symmetric because it's the same on both sides. And that's kind of what we're doing here. We're just going to do it a little more generalized with a little bit more math to it. So there are three kinds of symmetry we're going to first talk about. And one of those is symmetry with respect to the x-axis. Okay, so what does it mean if something is symmetric to the x-axis? Well, if you flipped it over the x-axis, right, it should map right onto it. So let's just draw something here, random. All right, say that's my drawing. And we notice that this drawing goes through this point here. And let's say that point is -2, 1, 2, 3, 4, 5, 6. Now, if it was symmetric with respect to the x-axis, then what other point do you know must be on the graph? -2, -6. Very good. Okay, that point is right there. Okay, and the graph then must also go through that point, right? And this is going to be close. Right, looks something like that. But you know that this point down here, -2, -6, is also on the graph. Okay, and so think about all these points that are on there. Say that this point here is 3, 1. Well, then it has to match up with a point here that's 3, -1 that must also be on there. So if it's symmetric with respect to the x-axis, then you have the exact same x and then the opposite y, right? The positive and negative of that y should be on there. So this is the way that we say that in a math statement. I'm going to write this down. This will probably be a good note for you to have. If a graph is symmetric with respect to x-axis, I looked at this. I've got my if in the wrong statement. That's not where I want to say it. Let's just start with the word a. It says a graph is symmetric with respect to the x-axis if xy is a point then x -y must be on graph. And this is basically what we were saying before. So it says if a point xy, so say 3, 1, is on the graph, well then x -y must also be on there, which would be here, 3, -1. Okay, so I'm looking now, instead of symmetry with the x-axis, I'm talking about symmetry with the y-axis. So straight up and down. Now we talked a little bit about symmetry with respect to the y-axis or with respect to any axis of symmetry on Friday. Does anybody remember when we talked about that on Friday? A parabola. And we talked about x equals -b over 2a and our axis of symmetry. Well, that is a vertical axis of symmetry. that sometimes can happen at the y-axis and sometimes doesn't. But let's just pretend here that I've got a parabola that is symmetric right there with respect to the y-axis. So say it looked like this. Let's draw it better than that. Oh. Hey, I'll get it in a second. I'm happy with that. Now, for this to be symmetric with the y-axis, let's think about some of the points that we see here. The one that I tried to go through is this one here. 1, 2, 3, which is 4, 0. So for it to be symmetric with the y-axis, what other point must also be on this graph? Negative 4, 0, right? It must go through this point to maintain that symmetry. And thanks to my drawing, it's not going to look symmetric at all. But all parabolas have that symmetry, vertical symmetry. And this time it just happens to be the y-axis. Okay, symmetry with respect to the y-axis. Now, does anybody know what the equation to this parabola would look like? No, we haven't talked about that yet. But we know what the general form of a parabola looks like. The equation is y equals x squared. Right? And now let's make our statement here for this, just like we did before. A graph has symmetry with the y-axis if xy is on graph, then negative xy must also be on graph. Okay, I'm going to show you how that plays out. So, we know that a parabola, right here, a general parabola, should be symmetric with respect to the y-axis. All right? This is how we can test that. If xy is a point on this graph and it has symmetry with the y-axis, so I'm checking for y-axis symmetry, then negative xy must also be on there. So this is what you do. You write down your given equation, y equals x squared. Now we substitute in, instead of xy, we're going to say negative xy. So that new equation would say y equals negative x squared. Well, what is negative x squared? If I take something that's negative and I square it, it becomes positive. So negative x squared is x squared. So notice, even when I plugged in negative xy, what happened to my equation? It went back to the original equation and looked just like it. When that happens, that means symmetry exists. This is also how you test for symmetry with the x-axis. And then there's one more type of symmetry that we're going to talk about on the next slide. Okay, now this last kind of symmetry, I'm not even going to attempt to draw. Okay, I couldn't draw that at all. But it's called symmetry with respect to the origin. Right, and you see kind of what that looks like here, where there's some symmetry with the origin. Now this is the way that I think back on all of them. If there was symmetry with respect to the x-axis, we talk about just flipping our original graph over the x-axis. Right? And when we do that, it should map right on top of it. Everybody say that? Imagine folding it over. Now similarly, look at symmetry with respect to the y-axis. we're going to fold that over the y-axis, and they'll match right on top of each other. Okay? But I think about symmetry with the origin a little differently. I think about taking this original graph, and I'm going to spin it 180 degrees, keeping my finger down on the place right there that's the origin. All right? So think about it. I'm holding that red graph down here. I'm grabbing the end up at the top right, and I'm spinning it around. All right? Holding the origin down. Does it match exactly on it? It does. Okay? So think about rotating 180 degrees when you think about symmetry with respect to the origin. And now our statement for symmetry with respect to the origin, a graph has symmetry with respect to the origin if the point xy is on my graph, then negative x, negative y is also on the graph. So now I'm going to look at example 1, but I'm not going to necessarily do what it's asking right now. I'm going to break this into 2 parts, okay? And this is what basically all of our problems are going to look like for this section. I know it tells me to find intercepts. We'll talk about that in a second. But what I'm going to do instead is I want to know, does y equal x squared minus 4 have any symmetry? Okay, so I have to test all 3 kinds of symmetry. I'm going to test x-axis symmetry. I'm going to test y-axis symmetry. And I'm going to test origin symmetry. And we're going to use those statements that we made to test each one. Okay, and if you look at me, this is the way I think about it, okay? Because you're not going to give those notes on the test, right? If I think about something being symmetric with the x-axis, well, the x-axis is horizontal, like this. So say that I had a point here, and it needs to be symmetric here, right beneath it, right? So what is changing? Is it my x or my y? The y is changing, right? The y is changing its sign from positive to negative or negative to positive. So to test for symmetry with the x-axis, I'm going to change the sign of my y. Okay, so we look at our original equation that was y equals x squared minus 4. If it has symmetry with respect to the x-axis, then that means negative y is going to equal x squared minus 4. Now, is this statement and my original statement, are they saying the same thing? They are not. This one is positive y, this one is negative y, and they do not say the same thing. Therefore, there is no symmetry with respect to the x-axis. Okay? Now, let's test for the y-axis. So, same thing. Y-axis is vertical. If I had a point on one side, and it flipped to the other side of the y-axis, that's changing the sign of my x. So to test for y-axis symmetry, I'm going to change the sign of my x. So this is y equals negative x squared minus 4. What is negative x squared? That's just positive x squared. Negative times a negative is positive. So when I simplify that, is this the same as my original? It is. So this graph has symmetry with respect to the y-axis. Okay? And then lastly, we will check for symmetry with respect to the origin. So for the origin, we change both the x and the y. So that would say negative y is equal to negative x squared minus 4. Now again, I can simplify negative x squared, negative squared is positive x squared minus 4. Then I bring down the negative y equals that. Now, is this statement the same as my original? No, it is not. So there is not any symmetry with respect to the origin. So the only kind of symmetry that exists for x squared minus 4 is y-axis symmetry. Okay, so for this next one, I'm going to let you do some of the work for me. We're going to talk about how to find x-intercepts and y-intercepts from an equation. All right, so again, last section, we had a graph and we had to identify where the intercepts were. All right, but now then, let's think about doing it from an equation standpoint. So what I want you to do for me is I want you to graph an x-intercept for me, just anywhere. Yeah, you can just click wherever there's an x-intercept. Graph any x-intercept.
Other.
Beautiful. Okay. Graph me an x-intercept. Excellent. Fantastic. Beautimous. Oh no. Oh no.
I did it wrong.
Yes, you did. Yes, very good. And one more.
Hold on.
Good. Now, what do we notice about each one of these x-intercepts? Let's look first at the yellow one. If I wrote the ordered pair for the yellow x-intercept, what would I get? Like, what is that point? It's at negative 6, 0. Okay, what about the blue one? What's its ordered pair? The green one? Positive 2, 0. And the red one is? So what do you notice about every one of these x-intercepts? Just any statements that you notice. They're all on the x-axis, something else. They are all different, something else. Yes. Every x-intercept has a y value that is equal to 0. Always. And we can use that algebraically. Now, on the flip side, think if I was dealing only with y-intercepts. I'm trying to see if I can change colors. There it was. Okay, so say that I have a y-intercept here, and here, and I had another one here. Okay, what are these values? Well, this one is 0, 4. This one is 0, negative 3. So every y-intercept, what happens? The x is 0. So every y-intercept has an x value of 0, and every x-intercept, the y value, no, I said that backwards. Every y-intercept, the x value is 0. Every x-intercept, the y value is 0. And we're going to use that to find intercepts. So let's go back to that original problem that we had before, where it tells me to find the x and the y-intercepts. Now we already know this has symmetry with respect to the y-axis because we found that earlier. Now we're going to find the x-intercepts and the y-intercepts. So what is it we knew happened at every x-intercept? The y value is 0. So I'm going to take my equation, which is y equals x squared minus 4, and I'm going to plug in 0 for y. That says 0 equals x squared minus 4. Now we solve this to find out what x is when y is 0. Move the negative 4 over. That gives us 4 equals x squared. This is going to be a great video. We're going to take a square root of both sides. When we do that, that gives me close. Remember what we talked about last section. Anytime you ever choose to take a square root, you must always account for the positive or the negative. So this has two x-intercepts. at positive and negative 2. Okay, so negative 2, 0. I'm running out of room on my iPad. I can't write a comma. There we go, that's close. And 2, 0. Those are my two x-intercepts. Now, we go over here and we decide to find the y-intercepts. This starts the process all over. I see it every year. People want to go from here and then try to find the y-intercepts. No, you got to start back from the very beginning. Whole new process. So now my original equation is y equals x squared minus 4. Now what was true at every y-intercept? X is 0. So this says y equals 0 squared minus 4, which says y is negative 4. So my y-intercept is 0, negative 4. Now I've found all of my intercepts, and I also know where the symmetry exists. So let's try to graph this. Okay, so I'm going to start by graphing my x-intercepts. Those x-intercepts occurred at negative 2, 0 and 2, 0. The y-intercept was at 0, negative 4. And we had symmetry with respect to the y-axis. I should have lightened that up. Give me just a second. That's my fault. Here we go. Now you can even see it. Let me make it a little bit... but I'm telling you, this is going to be a great video. There we go. You can kind of see that. Okay, so this is my dashed line of symmetry. Right, all the way through. Because we said it had symmetry with respect to the y-axis. Now we know, since this is an x squared equation, that the graph should look like a parabola. And so I don't have all of the features, but I have a general idea of what this graph's going to look like. Right, it's going to shape down. It's going to make a U, not a V. And it's going to start working its way back up. Boy, that's beautiful. Just get used to it. This is the way I graph all of my parabolas. I'm a terrible drawer. So I found it looks a lot better when I do this. I promise.
If you flipped it over, you could draw eyes.
Yeah, flip it over.
Yeah, give them a person. So now we're given an equation. Y equals x squared minus 4 over x squared plus 1. First thing we want to do is test for symmetry. Okay? Let's just test for symmetry first. So I want to know, is there x-axis symmetry? Is there y-axis symmetry? And is there origin symmetry? Okay, so again, you've got your notes right now you can look at, but this is the way I would think about it on the test. If it has symmetry with the x-axis, which is horizontal, then think about it has to be the same on both sides, which means the y value is changing. So I'm going to change my y value from a positive to a negative. When I do that, my new equation is negative y equals x squared minus 4 over x squared plus 1. Now there's really nothing left to simplify. Is this the same as what I started with? No, it's not. So there is no symmetry with respect to the x-axis.
Is there ever going to be x-axis?
Yes. Yes. Now, not if it's a function, but that's a whole... You're probably trying to think of functions. We'll talk about that later. Okay? Now, let's test, is there any symmetry with respect to the y-axis? So the y-axis is vertical, so we're going to change the sign of our x. So this would be y equals negative x squared minus 4 over negative x squared plus 1. Now I can simplify this sum. When you square something that's negative, it becomes positive. So this is x squared minus 4 over x squared plus 1. Is this what I started with? Yes, it is. So there is symmetry with respect to the y-axis. So I know on my graph that's going to exist. Now lastly, let's check with respect to the origin. The origin changes both the signs of the x and the y. So this would be negative y equals negative x squared minus 4 over negative x squared plus 1. Okay, as I finish simplifying this, those negative x that are squared, they become positive x squareds. Okay, but what's the problem? This side looks the same, but now the left side doesn't. It's got a change sign. So that means that it is not symmetric with respect to the origin. So the only symmetry that exists is with the y-axis. Now, the next thing we want to do is we want to find our intercepts. Okay, so my equation was y equals x squared minus 4 over x squared plus 1. So let's first find our x-intercepts. The x-intercepts happen when? When the y value is equal to 0. So that gives me 0 equals x squared minus 4 over x squared plus 1. Now the more you're with me, there's several ways you can go about this to try to get x by itself. Well, to me, every time I see a fraction equal to something, I always write a fraction equal to a fraction. Every single time. And then when I have a fraction equal to a fraction, I cross multiply and set those things equal. You'll see me do that over and over and over. So just get used to it. So now what's 1 times x squared minus 4? That's x squared minus 4. And 0 times whatever is 0. Now solve for x. So this says x squared is equal to 4. Square root of both sides. That says plus or minus what? Very good. So x is plus or minus 2. So my x-intercepts are at negative 2, 0 and at 2, 0. Good. Now, let's look for y-intercepts. Y-intercepts happen when x is 0. So that's y equals 0 squared minus 4 over 0 squared plus 1, which leaves me with negative 4 over 1, which is just negative 4. No, it's not always like that. So my y-intercept is at 0, negative 4. So later on we're going to talk a little bit more about what the graphs look like and how to graph them. But just for now, we're just going to save the graphing for your graphing calculators. We can enter it in. We'll practice that tomorrow. But this one's already been graphed for us in the book. And there were some comments made that this is probably the same graph because it has the same x and y intercepts and because it has the same symmetry. But if you remember what our graph looked like the last time, it was a parabola. Does this look like a parabola? It is not. But do you still see the symmetry? Do you still see the intercepts? So just because those match does not mean it's the same graph. That's a good point. At these next slides, I'm going to take a picture of your problem. And I'm going to put the answers underneath it so you can check.